Let's continue with our introduction to solving linear inequalities. The addition property of inequalities is going to be pretty much identical to the addition property of solving equations, and you'll find that we can add or subtract whatever we want to both sides of our inequality, and it remains an equivalent inequality. So let's go ahead and follow that same process. And again, the only difference from solving equations is that we have an inequality symbol rather than an equal sign. So we want to solve for x. Then we'll graph the solution and write the solution in interval notation. So we'll start with x minus 2 is less than 5. To solve for x, we need to isolate x. Well, in order to get rid of the minus 2, we can add 2 to both sides of our equation. And therefore x will be greater than 5 plus 2 is 7. We can graph this on our number line starting at 7, and because it doesn't have the or equal to, we're going to use an open circle, and x is less than 7, so we shade everything to the left. Our interval notation would be from our lowest value, negative infinity, to our greatest value of 7, with parentheses on both of those. Let's continue solving. X minus 5, we can subtract 5 from both sides of our equation. To isolate x, we bring down the inequality symbol. 9 minus 5 is 4. We have our solution set at 4. X is greater than, we have an open circle shading to the right. And then our inequality will, or our interval notation will be from 4 to infinity. For our next one, we have to move our variables as well as our constants. So we can go ahead and subtract 2x from both sides. X plus 4 is greater than or equal to negative 6. Then we go ahead and subtract 4. Make that a little thinner. Subtract 4 from both sides. X is greater than or equal to negative 10. So we can go ahead and graph on our number line, starting at negative 10. X is greater than or equal to, so we'll use that closed circle and go to the right. Interval notation, our lowest value is negative 10, continuing forever to infinity. So we'll use a bracket and a parentheses for that interval. Next one, we'll keep going. We want to subtract x from 2x from both sides. X plus 1 is less than or equal to negative 3. Then we can subtract 1 from both sides. X is less than or equal to negative 4. We can graph that on our number line. Less than or equal to means we're going to have a closed circle, and we will shade to the left. Our interval will be from negative infinity to negative 4 with a parentheses and a bracket. So here you can compare the graphs of the solution sets to the inequality symbol that's used and the way that it's represented in interval notation. Now, the multiplication property is very similar to the multiplication property of equations, but we do have a slight difference. Whenever we are multiplying or dividing by a value that is negative, the direction of the inequality will change. Let's take a look at why. Let's start with a true inequality such that negative 3 is less than 7. Well, let's go ahead and take both sides and multiply by 2 and see what happens. We'll take negative 3 is less than 7, and we'll apply our property. And we will go ahead and multiply, let's make that a little thinner. Multiply both sides by 2. So in this case, c is 2, and it is positive. We're left with negative 6 is less than 14. That is still true. Now let's do the same thing, but with a negative 2 instead. Negative 3 is less than 7. Here, c is negative 2, which means it's a negative value of c. Multiply the left and the right by negative 2. Negative 2 times negative 3 is a positive 6, is less than 7 times negative 2 is negative 14. This is false now. It is not true. 6 is not less than negative 14. Negative 14. But if we flip the inequality and we now have 6 is greater than negative 14, now it's true. So when we multiply by a negative value for c, we need to reverse the inequality so that it remains true. So again, when both sides of an inequality are multiplied or divided by a negative number, the direction of the inequality symbol must be reversed. So let's take a look at a few examples where that takes place. So we solve each inequality. We want to isolate x. So we have this fraction, so to get rid of this fraction over here, we can multiply both sides of our equation by 4. 4 times 1/4 is 1. X is less than or equal to 4 times 3/8 is 12/8, which we can reduce to 3/2. X is less than or equal to 3/2. Now we have to think, okay, did I multiply or divide by a negative value? No, these were positive. So I do not need to switch my inequality. So we can go ahead and graph 3/2. It's less than or equal to, so we'll have a closed circle, and we will shade everything to the left. Interval notation again would be negative infinity to 3/2. If you want to write that as a decimal, 1.5, that's fine. Now let's look at b. We need to isolate our variables, so we'll have to divide both sides by negative 2.3. Divide by negative 2.3. That cancels. We have x is less than negative 3. And then now we need to think, did I multiply or divide by a negative value? Yeah, c is negative. So I need to reverse that inequality sign. And so now it's actually going to be x is greater than negative 3. We can go ahead and graph it. Negative 3. We're going to have an open circle and shading to the right for greater than. And our interval notation will be from negative 3 to infinity, parentheses on both of those. Let's keep solving. We'll simplify using our distributive property. Negative x plus 3 plus 2 is less than or equal to 6x minus 15 plus x. Now to make this simpler, we'll combine like terms, and we'll have negative x plus 5 is less than or equal to 7x minus 15. And to make it easier to read, generally with inequalities, regardless of the size of the magnitude of each coefficient, I like to move my variables to the left-hand side. It makes it easier to read. So we can subtract 7x from both sides and also subtract 5 from both sides so that the variables move to the left and the constants move to the right. Negative 8x is less than or equal to negative 20. And then we'll go ahead and divide both sides. Divide both sides by negative 8. And then x. And since we divided by a negative value, we need to flip our inequality. So x is greater than 20 over 8, which reduces down to 5 over 2. So we have 5/2. We can go ahead and graph that. 5/2, which is 2.5. 5 halves, which is 2.5. We're going to have a closed circle shaded to the right. Interval notation will be 5 halves with a bracket to infinity. Let's go ahead and get rid of our fractions by multiplying by our least common denominator. So we're left with 2x minus 6 is greater than 5x minus 5. Distribute again. We will subtract 5x from both sides and add 12 to both sides so that our constants move to the right and our variables move to the left. Negative 3x is greater than or equal to 7. Divide both sides by negative 3 and remember to flip our inequality. So we can go ahead and graph negative 7/3. We're going to have a closed circle, and we shade everything to the left for less than, and our interval notation will be negative infinity to negative 7/3 with a bracket and a parenthesis. Now we've got two more, and these are going to be very special. And we have special equation solutions. We also have special inequality solutions. So we distribute 2x plus 6 is greater than 2x plus 1. And we'll go ahead and subtract 2x from both sides. And when that happens, we're left with 6 is greater than 1. Well, just like with our equations, when our variables canceled, we had a special type of situation where it was either no solution or infinitely many solutions. So we have to look at the validity of the statement that's left behind. Is 6 greater than 1? Well, yes it is. It's true. And whenever we're left with a true statement, a statement that is always true, then our solution set is all real numbers. Well, how do we graph all real numbers? Well, that's actually really easy. We take our number line and we shade in everything. Our solution set is everything on that number line. Well, and then how do we write it in interval notation? Well, if it's all real numbers, the lowest value in the set of all real numbers is negative infinity, and the highest is positive infinity. So negative infinity to positive infinity is the interval notation that represents all real numbers. Well, let's take a look at our next one. I said we have a special equation, or a special inequality. We might be able to guess what's going to happen next. When we distribute, and we subtract 3x from both sides to group our variables. Same thing, they cancel, and we're left with 1 is less than negative 6. Well, is that a true statement? Is 1 less than negative 6? No, that is false. And when we're left with a false solution, that means that we have no solution. The set is empty. So our solution set is empty. Okay, so we could either use a curly bracket that is empty, or we can use the empty set signal. And when we're graphing it, we just leave it blank. It's an empty number line.